Okay, today is Tuesday, February 2nd. We're looking at DNA, single-celled multicellular, prokaryote, eukaryotes today. I want you to start off by looking at your grades. All grades have been updated. Midterm grades will be turned in by teachers on the 9th in the evening, so don't expect them to be early in the day. So we still have a few things to add to our list and then update grades. You guys did a great job on the 70 or better on the test, and then being exempt from previous assignments that you didn't turn in. So I'm going to stick to that pattern. We're going to go ahead and have assignments just as we've had. We're going to continue on our path, and every test you have, I will let you do the 70% or better. However, for midterm, if you haven't had a test to remove those past zeros, those will apply until we can see that you can accomplish the goal by not doing the assignments. That's kind of the idea is you have assignments to do. The idea of the assignments is not just to have you do something, it's to enrich your understanding of what you need to know. So, for example, the foldable that you had for biochemistry was meant to help you see those 4 different macromolecules and kind of put those ideas together. In our situation currently, you were able to use those on the test, which should have benefited you in the case of being able to answer those questions. So many of you did great and were able to be exempt from a lot of work. There were a lot of people who did their assignments that were able to get the 10 points bonus, so great job. The next thing on our list is to go through the PowerPoint just a little bit, and the last thing is to have an assignment over an article over twins. Let's go ahead and do our PowerPoint, and then we'll talk about the assignment. When we look at this here, you guys have your own copy. We're going to see that we have chromosomes and DNA. So here is the prokaryote, which is a single-celled organism that only is going to have simple, it has cytoplasm, it has DNA, and it has a capsule that it lives in. So this example is a bacteria. Prokaryotes are incredibly simple. They don't have complex cells like we do. They don't have mitochondria or all the other things that are available in a multicellular organism. So prokaryotes are single-celled. This is what they look like. They lack the nucleus that DNA is held in a multicellular organism. Multicellular organism, a eukaryote, is like us, humans, and we have complicated structures. We also have complicated DNA. We have where a parent donates half and the other parent donates half and creates a human being. When we look at eukaryotes, such as, like I said, multicellular, you're going to see that they vary in their amount of chromosomes. Fruit flies can have 8, carrots can have 18, and humans have 46. 46 total chromosomes. If we look here at this picture, we're going to see that there are 22, according to this, pairs of chromosomes. The last one is not a pair because it could be different. They're called your sex chromosomes. And XY would be a boy, and XX would be a girl. Girls can pass on XX, boys pass on their X or their Y. So you have the girl donating an X, and the boy determines the sex of a child. So technically the girl only donates one of her X's, not both at the same time, because you only have 2 of those chromosomes donated to each child. Here we have a chromosome picture. We're going to see that we have the different parts of the chromosome. We are held together in the center by a centromere. We'll see those later when we talk about cell division. We have a short arm and a long arm to the chromosome. If I were to split these 2 in half, a half of it would be a chromatid, the other half would be a chromatid. So keep that in mind on the structure. The purpose of looking at this is to look at the picture that we have there. I'm going to go ahead and use this picture here. If I blow this picture up a little bit, we're going to look at how it looks on this picture. So when I look at this picture, I'm going to see that I have a DNA structure. It looks like a ladder, a twisting ladder. This is called the double helix. A chromosome is the double helix, but it's when it's all wrapped up neat and tight inside the cell. If we didn't wrap up the double helix, it would take up too much room, and For example, one strand of DNA could be over 6 feet long. So we have to wrap it up to make it fit. Plus, it helps protect the DNA. So when we look at this from right to left, that is the DNA being wound up into a tight coil into a chromosome. So we have the double helix being wound up. You see it twisting, twisting, twisting. Then it comes here to where it picks up some histones that then wrap into a little ball called a nucleosome, and they continue to coil like a phone cord, an old phone cord, into a supercoil, and then it turns into a chromosome, and it's incredibly packed tight together. This is typically how cells are in the nucleus. They do this to protect themselves. It's safer this way. However, when the cell is going to make copies, it has to become unwound so that it can make a copy of the DNA. It has to unwind to be able to see these rungs of the ladder, which are the little stair steps, so you can see what the base pairs are. We'll talk about base pairs tomorrow. So, this is condensed, meaning the smallest it could possibly be. This is the biggest, unwound. So we only do that in order to make a copy. Again, it's to prevent any damage. It's only we only unwind to do duplication. And then we have a basic unit of DNA as a nucleosome. And then this is the picture. I ask you which side is the smallest and which is the largest. This is the largest because it's the longest. And this is the smallest because this is condensed and able to fit into our cells. This here wouldn't be able to fit. It's too big. So it unwinds only in order to make a copy. And it doesn't unwind totally all at one time. It unwinds and rewinds as it goes through the process. So that's how it's able to do it and still fit. Alright, that is it for today. Let's go back to our lesson to see our assignment, which is about twins. You're going to open the assignment. It is an article you're going to read. It's pretty simple. You'll go down here, read through it. It goes through types of twins, the risks, the statistics, fingerprints. It shows you types of them, cell division and everything. So make sure that you read this, and then your last part is to complete the assignment, which is to give me 3 things you learned about twins in that article. And it's just that simple. It's due on the 4th. It is worth 10 points. And that is it. Have a great day.